Hi, this is Brian Fogarty, and this is a video for Chapter 5 of the book Quantitative Social Science Data with R, second edition. So in this video, what we're going to do is take a quick look at variable transformations, or more specifically, variable functional form transformations. So this is where we want to square a variable, cube a variable, log a variable, something like that. We don't always, it really depends on data you're working with. So we're going to look at two different ways to do this using the variable age, because often age has a nonlinear relationship with other variables. So in our analysis, in statistical analysis, we might need to transform it to more accurately describe that relationship, that nonlinear relationship. So let's take a look at age. We're gonna look at the summary statistics. Again, we're a little ahead of ourselves. That's in Chapter 7, but let's just take a quick look. I think everyone can agree it's not we're doing stuff that's super fancy here. So we're going to use VF England age. All right. So it shows it goes from 18 to 88, and the mean is 49, so roughly 50. All right. So there's two ways we can create transformations. One is by creating a new variable. So let's do that first. We're going to create a new variable here. I'm going to add this to I feel bad for VF England in this series of videos. We've added so many variables to it. All right, so VF England, we're going to use mutate, and let's do two versions, all right? We are going to do age squared. All right, and we're going to do age log as well. So age squared equals, and so what we do is we're going to do age, and just to be very clear, we're going to put it in parentheses, and then use the up arrow, caret, whatever you want to call it, and then a 2. That takes care of it. Let's also include the age. What do I call it here? We can do log age. All right, so log age equals, and then we use the function log, and then age. That's it. So again, R, at the most basic level is a calculator. So that allows us to use some of these operators just like we would in a calculator. All right, let's see if this works, because I actually haven't done it like this before. Yep, it looks pretty good. I'm going to steal this line, and then let's just take a quick look. We just want to make sure, like, did this work like it should have, or at least are we seeing different values? Oh yeah. Squared is different here, and then the log should be different from the other ones. Oh yeah. Okay. All right. So that's one way we can do it, is just creating a new variable. The other way that we can do transformations is by using the I function. And so what this does is that it's like making a transformation on the fly, where you're not creating or changing, so you're not creating a new variable or changing the original variable. You're just applying it in a certain way, the transformation in a certain way within a specific function. This is nice if we really don't care that much about the new version of it or the new transformation. We're just doing it for some statistical reason. So let's see how this works. So we have our summary function, and then we're going to do capital I as a function. We're going to do VF England here, $, and then we're going to do age caret 2. So what that should do is that it should give us a summary statistics for the squared version. All right, there we go. And if we look here at this one and compare it to this one here, we see those are the same values, and we didn't need to create a new version of it. That's the same thing. Let's look at the log. I'm just going to steal that, put it here. It's going to look a little different, because what we're going to do is we are going to wrap the log function around this. So we have summary, then I, then log. So we have 3 open parentheses, we need 3 closed. All right, that looks good. Run that, and then again, compare this to the one that we actually created. They are the same. All right, so that's it. That's it. Just real quick video on how to do variable transformations. All right, so thanks for watching. I'll see you next time.